Welcome to the shop. I'm continuing in NQALHA Production Run 4, making 10 sets of parts, and each set of parts is 75 parts. That means I have to make 750 parts, so I better get busy. I spent the morning troubleshooting and adjusting the Tormach automated tool changer. The automated tool changer, the previous generation for the PCNC 1100, is a pretty borderline design that kind of barely works and requires a lot of really fiddly adjustment and sometimes goes out of adjustment. And yesterday, toward the end of my work, I noticed that the tool changer was misbehaving. So inside the cassette here, inside the carousel, there's a little steel fork that's held in place by two plastic screws. Now you might ask, why is it held in place with two plastic screws? Well, because when things go wrong, the screws are sacrificial and they break off, preventing damage to the rest of the machine. When I received the tool changer, of course, the whole thing came disassembled and I had to assemble it and set it up and adjust it and make it work. When I received it, it came with a big bag of plastic screws. And I wondered, why so many plastic screws? Well, didn't take long to find out. The machine every so often just decides that it's going to misbehave and breaks a screw, if I'm lucky. If I'm not so lucky, one of my nice carbide tools falls out, hits the table, and chips the tool. So, the new design Tormach, they've realized that this design basically sucks, and the new design uses an industry standard BT30 tapered tool holder, but there is no upgrade path other than selling the whole machine and buying a new one. So I adjust, I live with it, complain a little bit, and wish it was better. So today I'm going to be making another part using the standard setup with the blank in the right vise, the tooling plate in the left vise, work offset 3, work offset 1, 0 on top of the blank, 0 on top of the tooling plate. And then there will be a third and fourth operation where the part gets stood up on end using the special tall jaws and the end gets machined. So let's give this one a try. It's a known trusted tool path. But, like all tool paths, even the known trusted ones, I still take it really slow the first time through. So, okay, tool change, successful, didn't break a screw. Single block. Verify pre-feed height. Kinda adjust my nozzles a bit. And 5140 RPM, 10 inches per minute, fast peck, 60 thousandths per peck. Drill bits coming out more or less clean. Gonna be doing a counter bore now. I got my finger on the stop button every time it does a tool change because I'm all out of screws. If I break another screw, I'll be in trouble. Doing a peck cycle on this end mill to try to reduce the amount of buildup of the rat nest on the cutter, and even with a peck cycle, I'm still getting some buildup, and I'm not sure if I want to spend a whole lot more time dicking with it. single block, pre-feed correct, feed correct, 2,500 RPM, 10 inches per minute, 3/8 diameter drill, peck drill. I forget what the feed per peck is on this one. So I've now verified that the blank is being drilled correctly. Everything looks just fine. I'm going to go over and cut another blank. Probably cut two. So, just like before, my strategy is to do a first operation, put it over on the preparatory table, do another first operation, then, while I'm waiting for that part to complete, I'm deburring the first part because I don't want to have the machine idle while I'm deburring. I want to get the maximum production that I can. So after this blank has been drilled, I'm going to go ahead and put the part that I just deburred on the tooling plate, put in a new blank, and run what I call the combo tool path that does first and second operation in the same load. Also, I kind of moved the camera a little bit, the overhead camera, so it doesn't get my head in the shot as much as it did before. This is a reasonably simple part. There's not a whole lot going on in the first and second operation. The third and fourth operation are slightly more interesting, but really, we're just about out of complex parts. A lot of these parts, a lot of the 75 parts, are actually quite simple. And so it doesn't take quite as long. So let me go over here to the tooling plate, and once again, I'm using using a 3/8 socket screw going into a threaded hole, and using aluminum washers to avoid boogering up the surface. Okay, and then pop in another blank. And now I'm going to switch to the combo tool path, verify that yes, all of the tools are loaded correctly, and then since I haven't run the combo tool path this morning, I'm going to treat it as if it was a new tool path, being very careful, finger on the stop button, paying attention. single block. All looks well. The combo toolpath is just cut and pasted from the basic toolpath, and so if the single operation toolpath works, a very good chance that the combo toolpath is going to work as well, but just gonna be careful. I haven't made a set of NQALHA parts for, I don't know, I think it was sometime last year. So that's like, what, 8 months, 7 months? And so memory is faulty. Can't trust my memory. It's easy to assume that, well, it worked the last time I used it, but you know what they say about assume? If you assume, it makes an ass out of you and me. So let's see if the second operation works correctly. Loading up the aluminum shredder, roughing tool, single block. Looks like it's stopping at the correct height. Throw the old eyeball over there. Looks like, yes, in fact, it looks like it's in the right place. Doing it in 3 passes, like always. Yep, success. Got to be very careful with a tooling plate like this with protruding hold down screws. Got to be very, very careful that the rapids don't end up running the cutter into the screw. Okay, pre-feed correct, feed correct. Got enough stick out. Finish pass looking good, 5,140 RPM, 30 inches per minute. Taking a 15,000th finish cut. Barely skinning the surface. And move to the unload position. All is well. I'm going to go ahead and turn the camera off and just do my run here, and then come back and we'll do the third and fourth operation. The parts are getting easier. I've got one more, the most complicated part in the entire set is coming up soon. But most of the parts that remain, they get simpler every one I do. I tend to do the more complex ones earlier in the process and then leave the easy ones for later, but even the easy ones take time. I mean, the rapids on this machine are so slow, the tool change is so slow, that even the trivial ones take longer than I'd like. So I may end up doing some more optimization of some of the really, really simple ones just to try to get it done quicker. So see you later. And I just had to fiddle around with the GoPro a little bit because it was blinking like crazy and doing all sorts of stuff that didn't look right. And I don't know, I'm not sure I like that little guy that much anymore. So I've now set up the somewhat taller jaws using work offset 2. I have used the Heimer indicator to set X and Y 0 at the back left corner and use the Tormach tool setter to set the Z0 on the surface of the vise. So the operation that comes next going to be drilling a hole in this part, drilling and tapping a 1024 here, and profiling a kind of an odd little somewhat triangular rounded corner shape on this surface. This part is the back plate of the clamp mechanism, and the little clamping arms attach here with a shoulder screw, and the triangular shape is actually fairly carefully designed to function as a backstop and a gluing surface to glue a little piece of rubber to provide a little bit of resilience in the clamp, because the clamp is clamping glass and I don't want a solid metal clamping force, metal to metal clamping force. I want to have a little resilience. And so first of all, the O-rings are silicone rubber, and so that provides some resilience. And then I added that little bumper. I'm not absolutely sure that it's necessary. It may be that the O-rings have sufficient resilience, but they're not that hard to make, and it is part of the design, and I think I'm just going to go with it. I'm going to leave it like it is. So, once again, known trusted tool path. Going to treat it as if it was a new tool path, and just be careful. Okay, pre-feed height correct, feed height correct. And it looks good. And in addition to making the little triangular piece, I can probably optimize that tool path a little bit. I'm not sure it needs 2 passes, but in addition to optimizing, in addition to machining the little triangular piece, now let me pay attention to this. Stop yakking. Pre-feed correct. Feed correct. Pecking, fast peck, 5140, 10 inches per minute. Drill looks correct. And then the next operation is going to be a power tapping. And that is what happens when the automatic tool changer fails. I spent all morning working on it, trying to get it to work correctly. And that is a major annoyance. So, welcome to the world of CNC machining, where even if you spend the whole morning trying to make it work correctly. This thing is still, it's a borderline design that, I don't know, I haven't figured out exactly what the problem is. But I'm going to fix it, finish the operation, run the parts, put them in the vibratory feeder, and that's it. Thank you for watching. Too bad it didn't go as well as I wanted.